Question 5, a question about equilibrium. Sulfur trioxide decomposes to form sulfur dioxide and oxygen at temperature T1 according to the equilibrium shown below. So we've got a reversible reaction, an equilibrium reaction, where 2 moles of sulfur trioxide produces 2 moles of sulfur dioxide and 1 mole of oxygen. Let's have a look. So what would happen, say for example, if I increase the pressure? By Le Chatelier's principle, I'll try and lower the pressure, and to lower the pressure it will reduce or lower the volume. So I've got 3 moles of gas on the right hand side, only 2 moles of gas on the left hand side, so 3 moles of gas would go down to 2 moles of gas. That's if I increase the pressure. If I decrease the pressure, it would go the other way, and 2 moles of gas would expand to make 3 moles of gas, and it would shift the equilibrium to the right hand side. What would happen if I added a catalyst? Nothing, because that would just speed up the forward and backward reactions to an equal amount. Equilibrium will be reached more quickly. So what would happen if I increase the temperature? Well, to the right hand side, going from left to right, it's endothermic, so taking in heat. So if I increase the temperature, say for example, it would shift the equilibrium to the right hand side to try and lower the temperature, or oppose the change by Le Chatelier's principle and try and lower the temperature of the surroundings. If I lowered the temperature, it would shift to the left hand side. Okay, let's have a look what's happening here. So at the start, I've got sulfur trioxide, I've got no SO2 and no O2, so that's why the amounts of O2 are at 0. It's not shown SO2 on the graph, but then over time the amount of SO3 comes down, decreases, the concentration of SO3 decreases because the SO3 has been turned into SO2 and O2, and similarly because O2 is now started to be made, then the O2 is being made, and that's why we're seeing an increase in concentration of the O2. At some point they both start to level off, so when the concentrations of the SO3, SO2 and O2 no longer change, then equilibrium is established. So equilibrium has been established at time 3 when the concentrations of the O2 and the SO3 and the SO2 as well, if it was shown on the graph, would no longer change. State the time to the nearest minute when the equilibrium is first established. Okay, that's time 3. Explanation, then the concentrations of O2 and SO3 are no longer changing. Sketch on the graph in figure 4 how the concentration of sulfur dioxide changes over these 6 minutes. So sulfur dioxide is being made along with the oxygen, so it's going to start at 0 because there's none at the beginning. So it'll come through the origin at 0 and it'll increase. Now, every time 1 mole of oxygen is made, 2 moles of SO2 are made. So the height of this graph needs to go up to twice the amount of oxygen. So oxygen's on 1.5, so the SO2 will come up to 3. Now, equilibrium's been made established at time 3, so that's why when the concentration is going to level out, so it'll go through 0 up to 0.3, and at 3 minutes it will level out. It will look like that. .3, the temperature of the mixture is changed to T2, so that's a new temperature. Don't assume that that's a higher temperature, it might be a lower one, but it's a new temperature, and the mixture was left to establish a new equilibrium. The new equilibrium mixture, the concentration of sulfur trioxide was found to be 0.07. So it's 0.07, so the new concentration of sulfur trioxide is lower than it was at the first temperature. Deduce which of T1 and T2 is the higher temperature. Well, in actual fact, T2 is the higher temperature, and the explanation is because you've got less sulfur trioxide than you had before, you've got 0.07 rather than 0.1, because you've got less sulfur trioxide than before, the equilibrium has shifted to the right hand side. So it's moved or shifted to the right hand side in the endothermic direction, because the higher temperature means by Le Chatelier's principle, the equilibrium will oppose that change and try and increase the temperature. It can increase the temperature by moving in the forward direction towards the try and lower the temperature. So you've increased the temperature by Le Chatelier's principle, try and lower the temperature of the surroundings by moving to the right hand side, which is an endothermic reaction which will reduce the temperature of the surroundings.